Welcome, curious minds, to the next edition of Mathlete Minds. In this particular edition, we'll be delving deep into quadratic equations. Of course, quadratic equations are not as complex as they seem to be, provided we understand the basics of it thoroughly. To begin with, let us take the general form of a quadratic equation, which is ax squared plus bx plus c is equal to 0, a second degree equation where a should mandatorily be not equal to 0. Because if a is 0, we'll get a linear equation and a, b, c belong to R. These are some examples of quadratic equation where a is 3, b is minus 4 and c is plus 2. In this case, a is 6, b is minus 1 and c is minus 2. Identifying the quadratic equations. So here, of course, we need to understand how to identify a quadratic equation before proceeding to solve them. So let's take up this first one. It looks like a quadratic, but when we simplify this, we'll get here, this is equal to 5x. So this becomes equal to x cubed minus 5x plus 1 is equal to 0. So of course, this is not a quadratic equation because the degree of this equation is 3. This one, of course, definitely is a quadratic equation, though the constant is missing here. Either the b term or the c term can be 0, but the a term should be not equal to 0. So this is definitely a quadratic equation. In this case, it looks like a cubic equation, but if we simplify, let's see what do we get over here. So this becomes equal to x cubed minus 3x squared plus 3x minus 1 using the formula for a minus b the whole cube. So here x cube and x cube term get cancelled and we are left with 2x squared plus 4x plus 2 is equal to 0. So this from here we can take out 2 common and we are left with x squared plus 2x plus 1 is equal to 0. So this definitely is a quadratic equation. Initially it was looking like a cubic equation, but ultimately after simplification we get a quadratic equation. Determining an unknown value in a quadratic when its roots are given. So here the roots are given. Maximum roots a quadratic can have will be 2. And here one of the roots are given and we are asked to find out the value of k, that is the coefficient of x squared. So in order to find that, we simply need to substitute 2 in wherever we have x in this equation. So this will become k into 2 squared plus 2 into 2 minus 3 is equal to 0. So this becomes 4k plus 1 is equal to 0, which means k is equal to minus 1 upon 4. So the value of k, that is the coefficient of x squared, is minus 1 upon 4. In this case, x is equal to a. So we'll put a wherever we have x. So we get over here a squared minus a into a plus b plus k is equal to 0. So this becomes a squared minus ab plus k is equal to 0. So these two terms get cancelled and so k is equal to ab. So the value of the constant k over here is ab. Determining the roots of quadratic by factorization method. So this is the first method by which we need to find out the roots. So in this case, what we do is we take this value of a that is given here. Now here there's no coefficient, so we take it as 1. So 1 into 5 will multiply this with the constant over here, that is 5. So 1 into 5 is equal to 5. Now 5 is a prime number, so we can only rewrite it as a product of 1 and 5. Now this 1 and 5 will be utilized here to give us 6 over here, so that we break up the 6 in terms of 1 and 5. So we get here x squared plus 5x plus x plus 5 is equal to 0. So this becomes equal to x plus 5 plus 1, x plus 5 is equal to 0. So again we get here x plus 5 into x plus 1 is equal to 0. So x is either equal to minus 5 or minus 1. So these are the roots of this particular equation. In this case, we have the coefficient of a as 9 and the constant is 2. So 9 into 2 is 18. So now if we talk about the factors of this, we can have one set as 1 into 18, which is not going to serve our purpose. If I take 2 and 9, this is also not going to serve the purpose. If I take 3 and 6, definitely it is going to serve our purpose because 6 minus 3 is 3. So this is with the help of factors that we can do first by taking the product. Other ways you can take out the prime factors of 9. 9 can be taken as 3 into 3, and 2 being a prime, it has only the factors 1 and 2. So now if we combine 3 into 2, we get 6. 6 minus 3 is 3. So either of these methods you can take the help of. And so this becomes 9x squared minus 6x plus 3x minus 2 is equal to 0. From the first two terms, if we take out 3x common, this becomes 3x minus 2 plus 1. 3x minus 2 is equal to 0. So this becomes 3x minus 2 and 3x plus 1 is equal to 0. So x is either equal to 2 by 3 or minus 1 by 3. Now this is x squared minus 49 is equal to 0. So this can be done in two different ways. Either we can rewrite as x squared is equal to 49 and then say x is equal to root over 49. That means x is equal to plus minus 7. This is one. So both the roots will be either plus 7 or minus 7. Or we can do it this way, x squared minus 49 is equal to 0. We can rewrite it as x squared minus 7 squared is 0 and then apply the a squared minus b squared formula. So we get here is equal to 0. So each of these linear factors when equated to 0 will give us x is equal to 7 or x is equal to minus 7. So these are the two roots of this equation. In this case, a is 8 and c is 21. So if we multiply 8 and 21, we'll get here 168. Now, if we take the the factors of this, 1 and 168 is not going to help. 2 and we'll get here 84. This is not going to help. If we take 4 and this will become 42, this is not going to help. If we take 6 and this will become 6 2 is 12, 6 8 is 48. Now 28 minus 6 is 22. So we can rewrite this as 8x squared minus 28x plus 6x minus 21 is equal to 0. So this becomes 8x squared. From here we can take out 4x common. We are left with 2x minus how much? 2x minus 7. Plus here we can take out 3 common. So 2x minus 7 is equal to 0. So this becomes 2x minus 7 into 4x plus 3 is equal to 0. So equating again each of the linear factors, we get x is equal to 7 by 2 or minus 3 upon 4. Now this could also have been done differently. We can take the prime factors of 8 as 2 into 2 into 2 and the prime factors of 21 as 3 into 7. And then if we combine this so that we get 28 and 6. So 7 into 2 into 2, if we take these three factors, prime factors, and we get 28 and 3 into 2, that is another set of prime factors. So 28 minus 6 will give us 22. So this approach can also be taken. This approach can also be taken. Now here we notice that A is irrational and C is irrational. So in these cases, what we need to do now, when we multiply these two irrationals, root 2 into 5 root 2 will give us 10. Root 2 into root 2 becomes 2 and so this product is 10. Now 10 if we take as 1 and 10, it is not going to help. 2 and 5 definitely is going to help. So this can be rewritten as root 2x squared plus 5x plus 2x plus 5 root 2 is equal to 0. So this from the first two terms we can take out x common. We are left with root 2x plus 5 and from here last two terms root 2 common. So root 2x plus 5 is equal to 0. So root 2x plus 5 is one set of terms and x plus root 2 is another linear factor. So from both these linear factors we get x as minus 5 by root 2 or x as equal to minus root 2. This can be rationalized and written as minus 5 root 2 by 2 and this x is equal to minus root 2. Here you find the middle term as the irrational quantity. So 1 into 6 is equal to 6. Now factors of 6 can be 1 and 6 or 2 and 3. Now both these sets cannot help us. So what we need to do is again break up this 2 as root 2 into root 2 and keep this 3 as it is. Then we can make a combination of 3 root 2 and root 2, because 3 root 2 minus root 2 will give us 2 root 2, and 3 root 2 into 2 root 2 will give us 6. So this can be written as x square plus 3 root 2x minus root 2x minus 6 is equal to 0. So this becomes, from the first two terms we can take out x common, x plus 3 root 2, and from the last two terms minus root 2 is common, so x plus 3 root 2 is equal to 0. So x plus 3 root 2 is one factor and x minus root 2 is another linear factor. Equating each of them to 0, we get x is either root 2 or minus 3 root 2. So these are the roots of this equation. In this case, it is not given in the standard or general format. So first we'll convert this into standard format. So we get here 16x squared minus 10 is equal to 27x. So this can be rewritten as 16x squared minus 27x minus 10 is equal to 0. So this becomes, if we multiply 16 and 10, you get 160. Now 1 and 160 is definitely not going to help us. 2 and 80 is not going to help us. If we take 4 and 40, this is also not going to help us. So we take 5 and this becomes, this is 5, 3 is 15 and this will be 32 over here. So this becomes 16x squared minus 32x plus 5x minus 10 is equal to 0. So from the first two terms, we can take out 16x common, x minus 2 plus 5, x minus 2 is 0. So this becomes x minus 2 into 16x plus 5 is equal to 0. So x is either equal to 2 or minus 5 by 16. Now this could also have been done by taking the prime factors of 16. 16 prime factors are 2 into 2 into 2 into 2. And the prime factors of 10 are 2 into 5. So if we can combine them so that we get 32, that is 2 to the power of 5. If we take all the 2's together, that will be 2 to the power of 5 and 5 separate. So 32 minus 5 will give us 27. Now in this case, it is not written in the quadratic format. So first we convert this into the quadratic format by taking the LCM over here. So this becomes x plus 4 into x minus 7 is equal to, right hand side will remain as it is, 11 by 30. So this becomes x minus 7 minus x minus 4. So this x and x will get cancelled. We are left with minus 11 upon x squared minus 7x plus 4x minus 28 is equal to 11 upon 30. So this 11 and 11 gets cancelled. So we are left with minus 1 upon x squared minus 3x minus 28 is equal to 1 upon 30. So this becomes x squared minus 3x minus 28 is equal to minus 30. On further simplification, we get x squared minus 3x plus 2 is equal to 0. So this can again be factorized very simply. This becomes x squared minus 2x minus x plus 2 is equal to 0. So we can take out x common here, and with x minus 2 minus 1 common, x minus 2 is equal to 0. So x minus 2 and x minus 1 is equal to 0. So this becomes x is either equal to 2 or x is either equal to 1. So these are the two roots of this equation. In this case also, we are left with not given in the quadratic format. So here, but we need to keep in mind that there is this x term is here and this x term is there. So first we'll segregate the x terms and we'll write this equation as minus 1 by x is equal to 1 by a plus 1 by b. So this, on taking the LCM, we get x minus a minus b minus x. Upon this will become ax plus bx plus x squared is equal to b plus a upon ab. So this x and x will get cancelled. So we are left with minus a plus b upon ax plus bx plus x squared is equal to b plus a upon ab. So this b plus a and a plus b get cancelled. So we are left with minus 1 upon ax plus bx plus x squared is equal to 1 upon ab. So now if we cross multiply this, we get over here, this becomes equal to ax plus bx plus x square is equal to minus ab. This can be rewritten as x square plus ax plus bx plus ab is equal to 0. So now this can be simplified as x plus a plus b, x plus a is equal to 0. So we get here x plus a and x plus b as the two factors. So x is either equal to minus a or minus b. In this case also, it's not given in the quadratic format, but this is slightly different. So if we take the LCM here, we get x minus a plus b into x minus b upon x minus b into x minus a is equal to 2. So if we open up the bracket, we get here ax minus a square plus bx minus b square upon x squared minus ax minus bx plus ab is equal to 2. Nothing cancels, so we'll cross multiply this and we'll write it as ax minus a squared plus bx minus b squared is equal to 2x squared minus 2ax minus 2bx plus 2ab. Now, next what we do is shift this left-hand side terms to the right-hand side. So we are left with 2x squared minus 3ax minus 3bx plus a squared plus b squared plus 2ab is equal to 0. So this can be written as 2x squared minus 3x within bracket a plus b, and this will be a plus b the whole square is equal to 0. Now let us assume a plus b as c. So this becomes equal to 2x squared minus 3xc plus c square is equal to 0. We could have continued in this way also, but assuming it is equal to c makes our work easier. So this becomes 2x squared minus 2xc minus xc plus c square is equal to 0. So from the first two terms, 2x is common, x minus c minus c, x minus c is equal to 0. So x minus c is the common factor, 2x minus c is the left out. So x is equal to c, that is equal to a plus b, one solution. And the second solution is x is equal to a plus b by 2, which is c by 2. So these are the two roots of this equation. With that, we come to this end of this video. Hope you like the explanation. Kindly like, subscribe, and press the bell icon. Thank you for watching. We'll continue with this quadratic equations. In the next video, I'll come with more questions, more solutions.